Hey guys, welcome to a brand new coding tutorial. Just muting my sound there so that we don't get any unwanted noises. And as you notice, I have the Python shell open once again. If anyone has a preference for a language that they'd like to see me write in, for example, C, C++, Java, Basic if you're into Basic for some reason, um, yeah, even another language that's similar to Python, like Ruby or uh, or Perl, if you're into that. Um, those are all possible, of course. Um, and if you have even an obscure or perhaps a slightly unconventional language like Forth that you wanted to see something done in, I could make a special video around that. So yeah, don't be afraid to make suggestions. And if I actually need to adjust my window size here because we're not getting the entire window at the moment, which I think that'll do it. And now we're ready to start writing. So originally today I had intended to write a program that was going to, that was going to basically just calculate or generate, I should say, a simple Fibonacci sequence. You'll have to forgive me; it is somewhat early in the morning for me. But actually, I wanted to talk a little more about perhaps the fundamentals of code first. So, no matter which language you go to, there will always be a few things which remain constant, and those things are essentially variables, um, constants, which aren't that dissimilar from variables. Um, there are um, there are conditional statements. There's is usually some form of input-output. And finally, there are loops. Oh, oops, forgot functions. And just like in programming, there's a lot of copy and pasting. So yeah, there are variables, constants, functions, conditional statements, usually some form of input-output, and loops. Okay, so let's go through all these. So as you can see, that's the first form. Let's talk about, well, yeah, let's take it from the beginning. Okay, so variables. What's a variable? A variable is some place in memory storing some data. So if I in Python, in C++, I might have to say, like, I might have to declare the variable type, like integer a, and then say that's equal to something. In other languages, I may have to do other things. For our purposes here, we're just going to say a equals 0. So Python is interesting because it discerns the data type from from the value itself. So if I go a equals pizza, Python intuitively knows that a should be a string. So if I print a now, we see pizza. Okay, so but ignore that for now. Just focusing on a. So a is a variable. It could be anything. It could even be called anything, and it could be equal to, say, 42. That could happen. It can be equal literally to anything. Um, we should talk about value types. So right now anything is 42. That means anything is an integer, and so you can see that when I convert an integer to an integer, it's the same thing. I don't know any other way to prove that to you, other than just telling you it is indeed an integer. And what an integer is any whole number value. Any whole number value. Okay, so, oh no, I'm inheriting some of my, a couple of my profs do that. When they want to emphasize a point, they repeat themselves. My physics prof in particular. Anyway, so, right, getting back to it. But there are other kinds of number values. For example, if I go 42.0 or 42.1, which obviously is not a whole number, that's still possible. It's just not a, it's not an integer. In Python, I think it's a float, but it could be a double. It's hard to discern the difference between those two. Basically, as far as I know, um, this would just be a float, which is basically any number with a floating point, I guess, or a decimal point, and it's a little harder to explain the difference between data types in Python because I'm not sure what data type is actually being used here. Like if double doesn't even exist, so it must be float. Yeah, it is a float. Okay. So all that means is that it has a decimal point. There's really no difference. If I go a equals 2 and then convert that to a float, um, you'll see it's just converted to 2.0. It just adds a decimal place. Why is that useful? If I go 42 divided by 7, jeez, what am I thinking? 42 divided by 8, I get 5. Now 5 obviously is not actually 42 divided by 8. Um, it's like that those two values aren't equivalent, so that's just the whole number portion of the float. But if I go 42.0 divided by 8.0, now the output is allowed to have decimal values, and you see it's 5.25. Um, yeah, so let's say I had 2 divided by 1.75. Well, we have an integer divided by a float. Will that work? Yes, it will. If I had 2.0 divided by, um, no, let's go 3.0. Oops, not 3 divided by 0. That will throw an error. Um, Divided by 2. Will that work? Yes, it will. So basically, yeah, as long as you have one of your values being with a decimal place, i.e., being a float, then you can do accurate division. If they're both integers, you'll just get the whole number portion. And let's see if I can yeah, that should be good enough, I think. Um, well, actually, if I go 3 divided by 2, it's just 1. Yeah, so it doesn't round up or anything. I just want to make sure. Conventionally, it wouldn't. I wasn't sure if Python did or not, because usually I avoid doing that. There is another way to get accurate, um, like, division out of integers, whole numbers, using the math library, if you or the math module, I should say, if you import math, you can, there's another way to do it. If I recall correctly, I never use that because it's totally pointless when you could just use floats. But yeah, it's personal preference, I guess, and maybe there are some instances where it would be cleaner. We're not even going to go over constants because constants are just variables that you can't change. So you would be like, I don't even know. Here's another thing. In Python, they have the help thing. Hmm. I don't even know if Python has constants. In other languages, you'd conventionally just go const, then your variable type, then your variable name, and then that equals like 3.1415926, 3.1415926 or 62. I don't remember. um, in Python, there is no easy way to declare a constant. I've just looked it up online. There is a method for doing it, but it involves using classes, which we haven't talked about yet, so I'm not going to get into that. So just for now, assume that I was wrong originally. Constants aren't in every language, um, but you can use variables to get the job done. So if I went like pi equals 3.14159, well, basically that's just a value which I leave constant. So I might want to go if I wrote a simple program like def circ oops def circ diameter, or we'll say r for radius, d equals r times 2, and then circ equals r, what am I doing? Yeah, no, I didn't. D times pi, right? Now actually, there you go. That's your little yeah, so basically pi is just a constant that I've declared here. Technically we could change this. There's nothing that states that it is constant um right now, but like conventionally it's just basically a variable which can never be changed after it's declared. So even though that's not really what we're doing here, the theory, I suppose, is the same, where you just leave something equal to a constant. Like, you don't want to be typing in 3.14159 all the time. Like, if you have a program that's that's like 40 pages long, you don't want to have to type in 3.14159 every single time. And even if you did, even if like the name of the variable was longer than the number itself, you may need to change the degree of precision, and you'd have to go back and change it in every single instance that you use 3.14159, rather than just at the very top be like, okay, now I want pi to be 3.1415926 or whatever it is. Um, so yeah, um, so here if we just print our circ, that should be a valid program. So now if I go circ and then say we want a radius of 5, it gives me my circumference just by multiplying diameter by pi. So yeah, and I mean everybody knows that. I hope that wasn't I hope well, I mean not everybody obviously. Like if for some reason you've never been exposed to math or whatever, or you just don't like circles or whatever, I can totally get behind you. Programming has nothing to do with circles, at least not intrinsically or anything like that, or innately I should say, but there is a math component, I would say, to programming. So where are we now? So we've covered variables and constants in 15 minutes. Um, so now we're on to conditional statements and input and output. Let me do input output first. So input output, what's that? Well, at its most basic level, some variable equals input input something, please. So, in Python, 55. So this might have gone a little fast for you, but in Python, p equals input. Okay, so what are we doing here? We're declaring a variable, p. We're saying it's equal to whatever value is passed in this input statement. So here in here in the green, if you notice, I have input something please. That's our prompt. That's how we're prompting the user. Not every language will allow you to prompt the user and take input in the same line. Python does, or using the same command, I should say. Python does. Not all languages will. So all this does is it outputs input something please, and then waits until the user hits the return key. When the user hits enter or the return key, it'll take whatever value they have there and store that in p. And I can prove that because right here, as you notice, p is now 55. Now, I know what you're thinking. How will we ever know what data type p is? Well, the good people at Python thought of a way around that. If you go p equals raw input, and I go 55 now, and then hit p, you notice it's p, but it's in quotes, okay? That means that this is a string. And I can prove that because 55 plus 55, as you can see, is 110. But 55 plus 55 as a string won't work because you can't concatenate a string and an integer. And I can prove that by saying p plus 55, same error. You can't concatenate, which means to add together a string and an integer using the plus operand. However, you can concatenate them like this. P plus, if I convert them to a string, I get 55555. Obviously not 55 times plus 55. If I go p plus p, p plus p, that will work too. So as you can see, raw input always returns it as a string, not as an integer or a float, but as a string. A string is something that holds only characters. It holds like if it's holding 55, but it's holding it as a set of characters, not as a number, which math can be performed on. However, we can convert this to a number. If I say p equals p plus p, just to show you what p is now, we can convert this to a number using conditional statements. So if p is digit, and this is digit thing, that's just something that comes standard in Python. We'll talk about that in just a second. If p is digit, then what do we want to do? So we have a condition. If p is a digit, right? If it's a number, like if it contains a number, well, we want to make it a number. We want to convert it to one. P equals p, int p. Perfectly fine, right? So let's say I have so now if I check p, it's converted to a number. I can tell because if I go p plus p, I won't get 5555 5555. I will get 11110. 11,110. Perfect. Perfect. So if I go back to my input here and now input something that's not a digit, like let's say pizza pie is loved by the sky, then now if I do this, it will fail. And as you can see, P was not turned into a digit, and if I add them together, we don't get any sort of weird error where, oh, and if you want to see what happens, if I go int P right now, we get a big error because P isn't a number. So as you can see, this is a conditional statement. If this statement is true, if P is a digit, convert it to an integer, convert it to a digit. If it's not, don't do anything. We don't want to do that because they'll throw an error. Okay, that's an example of a conditional statement. You can also have something like this, def condish, where I can say P equals 3 if P is greater than 2. We want to print, I told you all these years they mocked me, but I knew. And then we have something called the else statement. So we actually have two things. We have else if, or elif, P is greater than 3, then we want to say print. Dang, I really called it wrong this time. And then if I have else, print shoe. So what does this mean? So actually what I'm going to do instead is have my conditional P. Okay, so if P is greater than 2, we'll say if P is less than 1. So if P is greater than 2, then do this. If P is less than, we'll say 0, actually, do this. Else, if anything else possibly happens, do this. So let's see what happens when we run this now. If I go conditional of 4, we should get the first one. I told you all these years they mocked me, but I knew it. Awesome, that's what we want. If I go conditional of the second one, which is if it's less than 0, so we're going to say -2. Dang, I really called it wrong this time, which is exactly what we were looking for. And finally, if I go conditional of anything else, so 1 for instance, I get shoe. So as you can see, that's basically how conditional statements work. It's just if, else, if, else, if, and else. You get to specify cases, as many as you want. You can have as many else ifs as you want, and they execute sequentially. So like, it checks first if P is greater than 2. If it's not, it moves on to else if P is less than 0. So like, you could have if P is greater than 2, then if P is greater than 1, if P is greater than 0, like all the way down the line until finally you're like, else, I don't care, or something like that. So the only thing that we have left to talk about really, I think, is functions and loops. Perfect, perfect. Those things go hand in hand. So if so what we've already been declaring functions. A function is just something which contains code that you can execute. So we've already been doing this. Maybe I should have talked about it earlier, and I considered doing that. But in Python, it's just def, or define, then the name of the function, like pizza, then any variables that the function contains. So if pizza contained cheese, type, and crust, and sauce, right? Then your function of pizza has cheese, crust, and sauce. And yeah, that's going to be our topping. So what we're going to do is we're going to print om nom nom, what a good pizza. I mean, has it has some kind of cheese, um, and and okay. So this function, all it does is it takes in 3 variables. So if I go pizza, this is how I execute a function. I say its name, then I pass in the necessary values. So as you can see, cheese, crust, sauce. And in fact, if I scroll down a little more, you guys aren't going to be able to see that. Cheese, crust, sauce. So as you can see right here, the first variable is cheese. So let's say matzah. I don't know how to spell anything. The crust. Actually, let's make it gross. Gross. So foot cheese. First, so we have foot cheese. Then we have comma um I don't know, burnt crust, and special sauce. Okay. Um, so if I run this now, you can see it just inserts each of these values where each of these variables used to be. So foot, burnt, and special in that order. So om nom nom. What a good. Well, not necessarily in that order. It can be. You can put them in any order that you want. But yeah. So the first one we're looking for is cheese. So that should have the value of foot. So om nom nom. What a good pizza. I mean, it has foot cheese and burnt crust and special sauce. It's so good. Okay, so that's basically how a function works. It's just you have your variables at the top there, um, and you can pass in any value to into those variables. So actually, if I really wanted to perfect this function, there's only one more thing I'd have to do, and that is to make sure cheese equals string cheese. String cheese. That's probably one that I should have thought of. Crust equals string crust and sauce. Um, theoretically I do that before I pass the inputs in, but whatever. There's not a whole lot. So if I go pizza and then I go like 9, 5, 7 or something like that, I still get like strings because we've converted them to strings. So it has 9 cheese, 5 crust, and 7 sauce. It's so good. As you can see, the values are just inserted in line. So that's wonderful. Okay, so anyway, the only other thing left to show you is loops. And it is getting to be a long episode. I know that, and I apologize sincerely. I hope that this is going to be helpful. The final thing we need to talk about, loops. So, there are 2 kinds that you'll probably like to be familiar with. The first one, if I just declare a variable c equals 0, and then I go while c is less than 5, print c, c equals c plus 1. So what am I doing here? I declared a variable named c that had 0 as its value. While c was less than the value 5, it's going to print out the value of c and then add 1 to the value of c. So c equals the old value of c plus 1. The new value of c equals the old value of c plus 1. Perfect. So now, if I execute this loop, you can see first it prints c, which is 0, 0, 1, 2, 3, 4. Then, after it prints out 4, it adds 1 to c to make c equal to 5. Then it says, while c is less than 5. Well, is c less than 5? No, it's not. End the loop. That's the first kind of loop. There is another kind of loop called a for loop. Now, a for loop pertains to a list. If I have list y, or just pizza, if I have pizza, a list in Python is declared by putting it in square brackets like that. So if I just have string ring ring fling ming and oops, don't put in and let's see, what else do you like on your pizza? And feet. That sounds appetizing. So pizza is a list containing 5 values. This is probably the most complicated thing to get your head around. It contains string, ring, fling, ming, and feet. So if I go for I, or any variable, it could be u, it could be kkil, it could be mjuy. Then I say in a certain list. This for loop, by the way, is only in Python, which is why this is kind of frustrating, because I'd love to show you a more conventional for loop, something like from C++, for instance, but at the moment I cannot. I might show it quickly in the next episode how that works. So what I can do is I can print mjuy. And then, as you notice, string, ring, fling, ming, feet. So what did this do? Well, mjuy is a variable which will be equal to each term in this list. Okay? So basically, it starts with the first term, then it moves on to the second term, then it moves on to the third term, then to the fourth term, then to the fifth term. And what we can do is we can then perform some kind of calculation on that list, or we can just print everything out. Maybe I want to know what's on that list. Maybe I prompted for a list, and maybe now I want to print that list back out to the user. Like, there's 1,000 uses for a for loop. They're incredibly effective, I would say, as a loop, as long as you're using lists. While loops obviously are just as versatile, more or less. In fact, you could do the same thing with a while loop. If I go c equals 0 and then say while c is less than len pizza minus 1, and then do that. While c is less than len pizza minus 1, we can then say print pizza of c, and then go c equals c plus 1. Don't worry if you don't understand that. I'm just trying to demonstrate that it is possible. Oopsie. I just realized I made a mistake. We don't have to subtract that by 1. Perfect. And that gives us feet. So c equals 0. Just do that again, and oh crap. Let me just copy, get rid of this minus 1. Jeez. Copy again. There we go. Now if c equals 0, finally, just to show you. Sorry about all that nonsense. Uh, yeah, anyway, yeah, just to show you it does work. String ring, fling, ming, feet. You can do the same thing with a while loop as you can with a for loop. In my opinion, it's more effective, or you know, more logical perhaps. Maybe a little cleaner to use a for loop, especially if you have like multiple instances of the loop, like a nestled for loop or something. Like I think that using like a bunch of while loops could be um, disastrous in that instance. But I mean, you know, it does have its uses occasionally. And of course, while loops that aren't used for like processing the items in a list or whatever are incredibly effective in their role. You know, if you just need to loop like some command or something 5 or 6 times for whatever reason, um, you know, that's incredibly useful for that. So I realize it's been a long episode. I know it's just like the logistics. I'd love to call this another episode 0, but I'm going to call it just programming fundamentals. Um, Actually, I'm going to call it Python fundamentals because this isn't really programming fundamentals. Um, so just to summarize, if you get nothing else out of this video, just know that variables are common to everything as far as I know. Functions are common to everything as far as I know. Um, if like conditional statements uh, are common to everything. And finally, loops, like the while loop, are common to everything. So these are your big players: while, if, function declaration, which does vary. It's always different. Like when you declare a function in Python, it's going to be different from declaring a function in C++. Um, but yeah, just the basic premise, like when to use functions, when to use loops, when to use if statements, when to use variables, that never changes. Like that's always going to be the same. The logic remains constant, the syntax changes. So I hope you enjoyed this video, and yeah, have a nice day.